On the surface, the electrical connection between Las Vegas and these Nevada hills isn't immediately obvious. For one thing, surveyors don't gamble. There's nothing random in the detailed precision of their maps, nor in their measurements that determine the height above sea level of each point on a predetermined grid. A line is drawn, connecting all points a certain height above sea level, and then repeated for other heights at regular intervals. To a practiced eye, the resulting contours of constant height give a clear representation of the real landscape. By the same token, the contours on this map give a clear representation of an electric field. These are contours of constant electric potential, and they too represent a terrain that has its ups and downs. When real ground goes up and down, the prudent traveler wants to know about it, because going uphill can be hard work. And exactly the same is true for electric potential. Moving up the incline of potential is hard work. And the steeper it is, the harder it is to climb. Of course, if the potential isn't changing, it takes no work at all. And if the potential decreases, the field is downhill all the way. In this analogy, electric potential is elevation, and electric field is the downward slope. To put it in more mathematical terms, the electric field is a negative derivative of the potential. Or, in other words, the potential is minus the integral of the electric field. The electric field of a single point charge is proportional to 1 over r squared. So its integral is proportional to 1 over r. For a single point charge, the direction of the field is pretty obvious. But what about more complicated situations? What does the electric field for this potential look like? Because it takes no work to move a charge along a curve of constant potential. There's no component of field in that direction. So the field is perpendicular to each equipotential at every point. And that's how it assumes its familiar shape. The familiar shape of even the most rugged terrain isn't all peaks and valleys. Some regions are perfectly flat and horizontal. A lake is a region of constant height above sea level. Just as a region of constant electric potential is created by a conductor in an electric field. And since electric potential is the same everywhere on the surface of a metal, the electric field is always perpendicular to that surface.